Welcome to part 2 of how to create shear force and bending moment diagram of frame element using finite element method. We have the formula for transformation and local stiffness matrix to the left. Now entering value in those formula for node 1. As mentioned in the part 1, correction note regarding the signs of sine and cosine terms. Later down the video I have corrected it. If the element 1 was horizontal, the transformation matrix would be identity matrix. For stiffness matrix, we need the values of area A, moment of inertia I, elastic modulus E, and length of the element. For element 1, it is derived from Pythagoras theorem of right angle isosceles triangle. Since A, I and E are in inches, converting the length from feet to inches. Now feeding those values into equations. The red font is used for negative values. Both transformation matrix and stiffness matrix are 6 by 6 matrix as there are two nodes. Now to obtain global stiffness matrix, we have to perform matrix multiplication of transpose of transformation matrix multiplied by local stiffness matrix multiplied by transformation matrix. To obtain the transpose of transformation matrix, row elements are converted to column elements while the column elements are arranged as the rows. Can you spot the mistake? The sign of sign terms will be corrected. Since both the sign terms are taken as negative in the video, the transpose of transformation matrix becomes equal to the transformation matrix itself, which is not the case. I am performing the second portion, that is the product of local stiffness matrix and transformation matrix first. The matrix multiplication is row into column. Once local stiffness matrix multiplied by transformation matrix is obtained, the result is again multiplied with transpose of transformation matrix. Correction note: signs of sine and cosine term in transformation matrix, signs and component of local stiffness matrix, Transpose of transformation matrix and the transformation matrix itself are different. So correct it as described before by changing the sign and selecting the related cell values to obtain the global stiffness matrix from transformation matrix and local stiffness matrix for the element 1. This ends part 2 of how to create shear force and bending moment diagram of frame element using finite element method.